Welcome to the variation video, part 1, range and IQR. I would really rather call variation dispersion because we have a calculation in statistics called variance, and that gets a little confusing. We could also call it spread. If you recall from the averages video, press your stat key, use choice 1 for edit, and let's put in this list of numbers. There are 4 main dispersion statistics: range, interquartile range, that's what we call IQR. There's variance and standard deviation. I'm going to focus on range and interquartile range in this video. So once we've got our data in our list, let's press Stat, arrow over to Calculate. Choose choice 1 bar stats. Your list is wherever you put your data. I put mine in L1. Your frequency is going to be blank because if we wanted a number entered twice, we entered it twice. Arrow down to Calculate and enter on that. As you can see, we've got our sample mean, 33.6 repeating forever. We've got our sum of our list. We've got the sum of squares of our list. SX, that's sample standard deviation, and I'll talk about that in part 2. Lowercase sigma x, that's population standard deviation. We'll talk about that in part 2. We got how many numbers are in our list. Now we get to these last 4 entries. The min, Q1, med, median, Q3, and max x. This is called the 5-number summary. That's because the minimum, that's the absolute smallest number. Q1, that's the first quartile. That says 1/4 of the data is 3.5 or less. The first quartile is really the 25th percentile. 25% of the data is no bigger than Q1. The median, well, that would really be the second quartile. It's the 50th percentile. But we never call it Q2 or 50th percentile. We just call it the median. Q3, that's the third quarter of the data. 3/4 of the data is no bigger than Q3. That's also the 75th percentile. 75% of the data is no bigger than Q3. Max x, well, we could think of that as the 4th quartile. We never call it that, we just call it the maximum. It's the 100th percentile. That means the minimum would be the 0th quartile, or Q0. That's how they all fit together. But let's look at this list of data we put in. The middle guy is the 8. That's our median, our 50th percentile. If we ignore the medians and say, oh, well, he's used up, so he doesn't count, and we just look at the numbers before, and we want the middle guy for that set, we would have to take the number in between the 2 and the 5. So we take 2 plus 5, divide by 2, 7 halves, 3.5. That's how our calculator got the first quartile. Same way over here. All of the numbers after the median, we want the middle guy. It's halfway between the 50 and the 100, and so Q3 is 75. And that's a fine way to calculate quartiles, but it's not the only way. We have a cheer in this class, and it goes like this. Statistics is vague. And we're going to chant that many times this semester, because another way to calculate quartiles, which is every bit as legitimate, would be to say, let's include the median in the first half of the data, and now the middle guy is 5. Let's include the median in the last half, because if I include it in the first half, I have to include it in the last half. And now Q sub 3 is 50. Those are both accurate quartile calculations, but they come out very different. When I first started teaching this class, my stat lab used one formula, and the TI-84 used a different one. That was not much fun. But fortunately now my stat lab will accept either calculation. If it's a multiple choice and they don't give you the choice you want, you should write a little note to your instructor why you chose what you chose. Let's talk about range, because that's a little vague as well. In this problem, range would be the maximum minus the minimum. That's 120 minus 1, which is 119. Now, range should be how many units it takes to accurately depict your set of numbers. So let's look at a different sample. Let's say we had a sample that consisted of 6, 7, 8, and 9. If I want to calculate range, I'm going to take my maximum minus my minimum and get 3. But notice if I want to graph my sample, I have 4 numbers in my sample, and my range says it's only 3 because I subtracted that 6 off. Years ago, we used to always have to do max minus min plus 1 when we calculated range. Statisticians have decided that that's not necessary, that most ranges are so large that plus or minus that 1 isn't that consequential. But if you have a really small sample, it can be important. So, is range max minus min? Or is it max minus min plus 1? My stat lab is going to use this method, and it's a fine method. If you're really, really precise, you should probably do it that way. It's your choice. And that concludes Dispersion Part 1.